Hello engineers, welcome to another video on low-level design. In this video, let's tackle sequence diagrams. I hope you're ready. Let's get started. So let's first start with the purpose of sequence diagrams. So as you can see from the title, it's called a sequence. So there is a sequence of something, right? So in this case, it is the sequence of events. Sequence of events. So it conveys the timeline of the events. So if you look through a sequence diagram, we can clearly see what happens first, followed by which step, followed by which step. We can see the communication between different actors and different objects. We can see the back and forth communication. We can see what is getting transmitted between them, what is getting returned, and things like that, right? So that is the purpose of sequence diagram. We use it to convey a timeline of events. So this is very useful to see who is involved in a particular use case, what is happening in a particular use case, and in which order, right? So that is the whole point of sequence diagram. Now let's quickly see what are the notations involved in sequence diagram. First, we have the actors, which are denoted using a stick figure. So these are the external users of our system, right? And then we have objects, which are inside the system. So these are the things we have converted from the real world into the digital world, and these are the objects interacting within the system. So the actors interact with the objects, and objects can interact back with the actors, or they can interact with other objects as well, right? And then we have the lifelines. Lifeline is denoted by a vertical line like this, vertical dashed line, and this denotes the period during which a particular object or an actor is part of the system. For example, if this is an actor and we convey the lifeline of the actor like this, and the messages go back and forth like this, right? And within the lifeline, if this is the entire lifeline of the use case, there can be certain period where this actor is particularly active, and then this actor remains silent throughout the rest of the use case. So that is conveyed by this activation bar. So this rectangle bar is used to convey the activation status. So that is the point of activation bar. Now let's look at messages. So the communication between actors and objects is happening through messages. Messages involve request and response structures. So request is going like this with a solid arrow, and the response is coming back like this with a dashed arrow, right? So it need not be in the same direction. There can be messages going back and forth in any direction, but if it is a request, we denote it like this, and if it is a response, we denote it using a dashed arrow like this, right? So this is how it goes. Let's say I am sending a message from an actor to an object like this. So both have their timelines, lifelines, and this is the first message, hi. And the object is responding back saying hi. And these are the activation bars for both of them. So they are both active for this particular exchange of messages. So as you can see, there is a solid arrow with a message on top. So this is what we will use to convey what is being sent. Is it a hi? Is it some kind of an object? Is it some kind of a cryptic message or anything like that, right? And similarly, the response structure. So in messages, we can do synchronous and asynchronous messages. Synchronous messages are blocking messages, which means that if a message is sent like this, a hi is sent like this, it means that I'm waiting for a response. So it is denoted by a solid arrow like this. This is synchronous message. So this is synchronous message, a solid arrow, solid headed arrow. And if it is asynchronous message, it is represented by a hollow arrow. So if it is a blocking request, we use a synchronous message. If it is a non-blocking request, we use a asynchronous message. So asynchronous is non-blocking. So if you want to convey a situation where one message is sent and it is waiting for a response, then we use synchronous. If it is the case that we send a message and we're not worried about the response, then we can use asynchronous messages. So there can be many use cases for this. We'll see in the examples, right? And then we have a self message, which is denoted like this with an activation bar and a self arrow like this. So if there is an event that is happening within a particular object or an actor itself, then we use a self message. For example, processing payment. If there is no one else involved in this, but this is a significant event that's happening in the use case, then we can use the self message, right? Now let's look at create and delete messages. So if there is a situation where we need to create a new object, then we can use this method to convey that information. So it goes like this. So this is the notation for create, and here we have the object. For example, if I am placing a order for booking a movie, so here the order is getting created. So I can convey the creation of that order using this create message. In the same way, we can also delete objects like this with a cross mark. It conveys that the object is now being deleted. So in this way, we can show the life cycle of an object using sequence diagrams. Okay. Now let's look at alternatives. Alternatives are a notation where we can use if-else cases. So for every request message, there need not be a single response message. There can be different responses depending on the context, right? For example, if I'm doing a login, I can do a successful login or an unsuccessful login. So if we want to convey that, we can use the concept of alternatives. So it is represented like this. So this is the representation of an alternative. Here we write what is the use case and what is the if case, what are the messages conveyed within if case, and what are the messages conveyed within the else case, right? So that is the concept of alternatives. So those are the main notations of a sequence diagram. Now let's take a look at some examples that I've drawn for you. Let's go to our charting platform. So I have created a new file called use case diagrams in the UML folder. You can check out the link in the description below. Let's start with a parking lot. Let's see who are the actors and what they are doing here, right? So I have a driver who's entering a vehicle number at the entry manager. So there is some kind of a entry system at the entrance of a parking lot where there is somebody operating it, or the driver themselves can operate it, but there is a way to enter a vehicle number. And then this entry manager will call upon the slots manager, who is responsible for taking care of the availability of slots, and then issue an available slot to this driver, right? So here is the lifeline of how this goes. So the entry manager initiated a transaction, and then the slots manager is checking for the available slots. So the slots manager has the data structure to hold all the parking slots. It has the state of each slot, whether it is full or available, unavailable, and things like that. So in this case, when we are checking for available slots, there can be two possible cases. So first is an unavailable case, and then there is an available case. If it is unavailable, we return a message saying parking is full, parking full, and then the entry manager can deny entry. And this is the available case, where we can say book a slot. So we go to the parking slot and mark it as booked, and then those details are sent back to the driver in a parking ticket type of format, right? So this is the use case. And then the driver goes to the respective parking slot and parks the vehicle, and this is happening offline. We don't need to do anything about it. And when the driver is ready to exit, the driver will come to the exit manager and initiate an exit transaction. And then the exit manager will request to release slot to the slots manager, and the slots manager will release the slot and then confirm the slot release to the exit manager, and exit manager will issue the exit receipt. Again, I have kept it as a very simple diagram because we want to learn sequence diagrams, and if you want to include payment methods and things like that, you can add them as well. So in this diagram, we can see the actors and we can see the lifelines. So the vertical bars are the lifelines, and then these blocks are the activation bars. You can see driver is pretty much using the system throughout, but the entry manager is coming here, and then the activation has stopped. The slots manager is working throughout the use case pretty much, and then the parking slot comes and goes, and then the exit manager is only active towards the end. So this is how we can convey the sequence of events using a sequence diagram, right? Let's go to the next example, which is food ordering. There are more players here. Let's see. Let's go through the timeline. First, we have the user, and user is requesting a list of restaurants. And in our system, we have the restaurant manager who is responsible for creating a restaurant, adding the menus, photos, and things like that. And when the request is given to the restaurant manager, it can return the list of restaurants. And for a particular restaurant, the user will request a menu and the restaurant will return a menu. And then the user will place an order with the order manager. Now order manager is creating a new order. This is the create message that we saw before, and this is the order object. So the order is created here during runtime, right? And then the order ID is returned back to the user, and the user can start making a payment with the payment manager, and payment manager is processing the payment and returning back the transaction ID. And the payment manager will notify the order manager that the payment has been made and you can proceed further. So at this point of time, the order manager will place an order with the restaurant. Restaurant is a user again here. Somebody at the restaurant will confirm back the order to the order manager, and the same is confirmed back to the user. So we are giving some kind of real-time updates to the user. And then the order manager is calling upon the delivery agent manager. So this manager is responsible for creating delivery agents and looking after their statuses and their payments and things like that. So this delivery manager is getting a request for an agent, and the manager is looking for available agents, and then agent is assigned. The agent details are passed down to order manager, and order manager will convey the same thing to the user. So we are again providing real-time updates to the user as and when they happen in the timeline, right? And then the delivery agent will go to the restaurant to pick up the food, and then we convey again the same message to the order manager, and order manager is passing down the information to the user, right? Through some kind of a notification, let's say. And then the driver will navigate to the location and then deliver food. So this is the high level use case, you can say, of the food delivery system, right? There are multiple players here, and we get to see different types of messages and exchanges between different players. So when we are doing sequence diagrams, instead of just doing user, food delivery platform, restaurant, agent, we can use this opportunity to drill deeper. For example, I could have done all these in just one object and call it food delivery system, but it gives me the opportunity to drill down into the backend system and divide the responsibilities among different managers. So we can see when we go deeper into this, where we will build class diagrams, it will be easier for us to distribute the responsibilities among different classes. So at this point of time, I'm able to clearly see that I need a restaurant manager class, I need an order manager class, and I need an order object, and I need a payment manager class who will take care of payments. I could also add a notification manager who will take care of notifications. So at this time, only order manager is taking care of forwarding the notifications to the user, but I could split it further to other notification manager if I need to, right? So use the sequence diagrams as an opportunity to drill down slightly deeper into the backend system, right? Now let's go to a third example, which is the elevator system. Let's see what's happening here. So on the left side, we have the user. User is interacting with an outer control panel, and the user is sending a request to the control panel whether user wants to go up or down. So we have these two buttons at the outer panel of any elevator system, right? So this is an elevator system with multiple elevators, and use of one button can summon one of the elevators for my use, right? So this request is passed to the queue to the elevator manager. So the elevator manager is the brain of the whole application, and it has the data structure to hold all the elevators, and elevators are already created and added to the system. Their states are maintained, whether they are going up, they are going down, what is their current location, which floor they are on, and things like that. So based on all these information, the elevator manager will run its own logic to find the available elevator and push a command to reach the user's floor. So basically to fulfill this request. So there is a request that is added to the queue, and the user will get the elevator to the floor. And then the elevator is going to reach the floor, and then it will convey to the elevator manager, okay, I have reached the state, and you can now mark this request as fulfilled. So the outer control panel is informed that this request is fulfilled. So that's where we see the light going off in the outer control panel saying that, okay, the lift is arrived now, it is ready for a new request, right? And then the user walks into the lift and presses a particular floor number in the inner control panel. So this is an inner control panel inside that particular elevator. So here we are not talking about a control panel across the elevators. This is inside one particular elevator. So if the user is pressing the floor, only that elevator needs to travel to that floor. So the floor number is pressed. Again, this will be added to the queue for the elevator manager to decide when to issue the command to reach that floor. So there can be multiple buttons being pushed, right? So depending on the sequence or the direction in which the elevator is going, this request is processed. So the command will come eventually to reach the desired floor, and then the elevator will reach the desired floor, and then the state is updated with the elevator manager, and the same is conveyed to the outer control panel that the request is fulfilled. So for every request, there is some kind of a life cycle. The request is given, it is added to the queue, the elevator manager will take care of when that request should be fulfilled, and then when it is fulfilled by any elevator, the elevators convey it back to the elevator manager, and the request is marked as completed, or it is simply removed from the queue and it is ready for a new message, right? So this is a simple elevator system which can operate multiple elevators, right? So in this diagram, let's notice the use of asynchronous messages. For example, if you see here, user is pressing a button to request an elevator to go up or down on the outer control panel. And when this request is added to the queue, this is an asynchronous message denoted by a hollow arrow, if you can see that. And the outer control panel does not need to know when that request is fulfilled. It is passed to the queue, and when the elevator manager is ready or when there are available elevators, the request will be fulfilled. So this is an asynchronous message. And then similarly, the elevator manager is issuing the command to the elevator, and the elevator will take time to reach the particular floor. So until that time, the elevator manager should not be blocked. It should be able to receive new incoming requests, right? So that is why this is another example of a asynchronous message, right? So those are the examples of sequence diagrams. I hope they were helpful to you. If you have any inputs on any of these diagrams, definitely let me know. I try to keep them simple for our practice purposes. So as a practice question, if you would like to continue from our previous video where we have drawn use case diagrams to buy a product from an e-commerce website, continue with that example and use the learnings from this video of sequence diagrams and make sequence diagrams in a new sheet or a new file and put them in the comment below so that I can check them out and provide any inputs for you, right? So that is all I had for this video, guys. That is the whole concept behind sequence diagrams. Thank you so much for watching. If you have any questions, definitely let me know. Do leave a like if you found this video helpful. It will help reach other viewers as well who are looking for such diagrams and low-level design concepts. And if you have any questions, put them in the comments below. I will try to address them for you. And thank you so much for watching. I will see you in the next one. Cheers.